Hi everyone, and welcome to this ASHRAE Ireland webinar on evolving HVAC guidance for airborne infection control, current status and future directions with Professor Bill Bahnfleth. My name is Daniel Coakley and I'll be chairing today's session. So the agenda for today's webinar is shown on the slide here. I'll start with a very brief introduction and cover some general housekeeping information before handing over to Bill, who's going to speak on the topic of evolving HVAC guidance and airborne infection control. And hopefully we'll have some time at the end for some Q&A from the audience, and I'll finish off with some closing announcements. So before we begin, just to highlight a couple of points regarding your participation in today's webinar. All attendees are muted, but if you want to ask a question, please use the questions tab or the chat function to submit your query, and we'll do our best to answer it during the seminar. If you have any difficulty or want to follow up afterwards, our email contact is provided. You can also access a PDF copy of today's presentation and some other useful reference material in the handouts tab. So I suggest downloading these because we'll move quite quickly through some of the slides. And there's also some links in the PDF copies that you can follow to access additional information. And lastly, when the seminar is concluded, you'll receive a very short survey, 3 questions, which we'd really appreciate your feedback on afterwards. So we're delighted to have the opportunity to host Professor Bahnfleth for a second time as part of the ASHRAE Ireland technical webinar series. He's previously spoken to us in July as part of our COVID-19 mini-series alongside representatives from CIBSE, REHVA and other experts in specialist topics such as monitoring, control and air cleaning. If you missed that seminar or any of the others, you can access the recordings and the slides on our website on the link shown here. Briefly also just to highlight, there's a lot of information available through ASHRAE, which is linked on this slide. So I'd advise you to download the handouts so you can access the links provided. Just to highlight a few of the main items, there's a lot of technical resources on the COVID-19 page. So topics including general guidance, building reopening, etc. The guidance in particular from the Epidemic Task Force, which Bill is going to cover in more detail in today's presentation. There are also a number of relevant position documents and core recommendations, one-page summaries of various guidance available on the website also. On the literature, there's also a link on the resources tab on the COVID-19 page that gives you free access to relevant sections of ASHRAE handbooks and standards and guidelines. And finally, the ASHRAE Learning Institute provides a series of instructor-led courses on relevant topics. There's also a very useful infographic which ASHRAE have produced to help you guide or navigate through all the resources that are available. And I've included a link, a copy in the handouts, so just open the PDF and that contains interactive links to all of the relevant sections. So I've already mentioned the ASHRAE Learning Institute. You can see here some of the upcoming presentations and seminars over the next couple of months. And there is also HVAC design and operation training level 1 and level 2 offered virtually until we can provide local training to members. So I'm now going to hand over to today's speaker, and as I said, I'm delighted that we can welcome back Professor Bahnfleth, Professor of Architectural Engineering at Penn State University and Fellow of ASHRAE, ASME and the International Society for Indoor Air Quality and Climate. Bill is also a past ASHRAE President, 2013-14, and has authored over 170 technical papers, 14 books and chapters. As I mentioned, Bill has been chairing the ASHRAE Epidemic Task Force, which consists of a team of over 130 volunteers that have produced a very comprehensive set of materials and guidance for COVID-19 mitigation in buildings and HVAC system. And today Bill is going to speak about the evolution of that guidance and what the future looks like for HVAC and airborne infection control. So I'm just going to make you presenter, Bill. And
all right, am I showing the correct slide here now?
Yes, perfect. Thank you.
Okay, very good. So thank you for the introduction, Daniel, and thank you for the invitation. Ireland Chapter, glad to be back after I think it's a little more than 6 months. And my talk today is noted as an update on the guidance that ASHRAE is producing that will describe how it's changed and why it's changed. And at the end, I'll say a few things about what I think the post-pandemic future might look like. So let's briefly review where this all started and where guidance was back in about May or June of last year. So one of the key questions we were asking at that time was, is airborne transmission of COVID-19 even possible? It may be hard to remember that at this point, but public health authorities like the World Health Organization and the CDC in the US were pretty convinced that airborne transmission didn't happen. I think mainly because they'd been looking for it in healthcare facilities that were very well ventilated and had high filter efficiencies. ASHRAE and REHVA and other HVAC organizations that were producing guidance took a somewhat different view. We were looking at case studies that suggested fairly strongly that something other than close range transmission was going on. And you may remember ASHRAE's statement that it seemed sufficiently likely that there was airborne transmission that we should do something about it. And this was all accompanied by lots of academic debate about whether there was airborne transmission. So we were applying the precautionary principle that we should take reasonable measures to avoid threats that are serious and plausible. And we felt that incidents like the Diamond Princess cruise ship and the Skagit Valley choir practice in Washington in the US and the famous Guangzhou restaurant incident provided enough evidence that there might be airborne transmission that we should do something about it. So really our key case study that everyone keeps going back to is this restaurant incident that was studied very thoroughly by several groups, but by one that included Yuguo Li from Hong Kong, ASHRAE fellow. And so this was an incident where there were 9 infections at 3 tables around a table where there was 1 pre-symptomatic infector. And the analysis of what was going on revealed that there was no mechanical ventilation and that the natural air change rate was 1 liter per second per person or less, and video showed no close contact. So it seemed fairly clear that a factor here was airborne transmission due to the concentration of infectious aerosol, affected to some extent by airflow patterns because the infections all occurred in the recirculation zone of 1 split air conditioner that was supplying air to the 3 tables where infections occurred. So this was an early key example, we thought, of community spread due to poor ventilation and that it was airborne in nature. Second question was do HVAC systems spread COVID-19? And to summarize this rather long statement that ASHRAE produced, in a nutshell, our position was that HVAC systems should be providing outdoor air and they should be filtering the air, so they're actually protective, and in most cases, if you turn them off, you're only going to make things worse. So those were the sorts of issues we were struggling with back in those days. In May of 2020, what we were calling ASHRAE guidance was really what was in the infectious aerosols position document, which was expedited to completion as one of the first things that the ETF, the Epidemic Task Force, assisted with, but it's not a task force document. And I want to point out that it's generic. It was not written as a guidance document or a standard, and it talks about measures that can be effective, but it's generally conservative and doesn't consider things like comfort or energy use or cost. And if you're still referring to it, now would be a good time to stop doing that, because it's not really ASHRAE's current guidance, and we're already in the process of starting to revise this document based on all of the things we've learned during the pandemic. So what was our initial guidance once the task force produced some recommendations? A lot of this draws on the position document. Increase outdoor air to 100% or as much as possible. Disable demand-controlled ventilation. Upgrade filters to MERV 13 or as high as possible, lower efficiency. Operate HVAC systems 24/7. Add in-room air cleaners if you can. Add upper room ultraviolet germicidal radiation if you can. Bypass energy recovery because it may result in reentry. And consider modifying temperature and humidity to reduce viral survival time. So you can see here the conservatism that was inherent in the initial recommendations, and also that a lot of these measures, which I've bolded, could result in a lot of increased energy use, and some of them could affect comfort in buildings as well. So that was our starting point, and now let's move on to what's new, what we learned after that stage in guidance development that has contributed to change. It didn't really result in change for ASHRAE, but it was nice to finally have public health authorities not saying that our position was wrong. So it took until about October of last year for WHO and CDC to finally make public statements that they believed that there were conditions in which airborne transmission could occur. They still stick to the three modes of transmission view of things, that close contact is the most important one, and they still are warning about fomite transmission, although there seems to be very little evidence that it's a significant mode. But we finally have acknowledgement of airborne transmission indoors from prolonged exposure with inadequate, in some sense, ventilation. But this effort to clarify what we mean by airborne transmission and how it should be viewed in terms of guidance development continues, and just within the last few weeks, another article was published that addresses myths in airborne transmission, and you may find that interesting to read. It's an open source paper that was written by the group that has interacted with WHO quite a bit, led by Lydia Maraska from Australia, and having many familiar names on the author list. So something else that was new was feedback. We got a lot of feedback about the initial guidance. It started almost immediately. Certainly, many were glad to have recommendations coming from ASHRAE, but they raised lots of questions. You've got a long list of things here. Do I have to do all of them? Which ones must I do? Which ones might I do? And when do I do the things that aren't absolutely mandatory? And what if I can't do some of these things? You say we should upgrade to a certain filter efficiency. I can't really do that for various reasons. What are my alternatives? We had a lot of questions come in about what the justification was for each recommendation. Who says that this is what we should be doing? Questions about cost, questions about energy impact, all very valid and important. And some concern that the recommendations that we were making were actually new standards. No, they aren't, but that's certainly a concern that many have had. And another question, which we were glad to see taken off the list, was why follow recommendations from ASHRAE if they aren't consistent with what WHO and CDC are saying? So those all informed our updates to guidance. And we did get information from research that's been ongoing that I wouldn't say changed ASHRAE's point of view, but at least helped answer some questions in a way that was consistent with what we had already concluded. And one of them was that SARS-CoV-2 containing aerosols can actually penetrate HVAC systems. That was something that many argued against, and then they used it as an argument for opposing some of our guidance that, well, there's no evidence that these infectious particles are actually making it into the return system and going through the HVAC. A study done by the University of Oregon at a hospital in the US found viral RNA throughout a hospital air handling unit. So actually downstream of a MERV 15 final filter on supply air dampers. So that question's answered. And another one was, is SARS-CoV-2 in the air actually infective? The assay methods that were used for a lot of the studies could only determine whether viral RNA was present, but not whether the virus was actually active. And we had a research study at a hospital in Florida that used a different sampling method and actually retrieved active SARS-CoV-2 virus from the air. So that question is answered as well. And we've had some interesting recent data on other modes of airborne transmission that are quite familiar to those who were following the original SARS epidemic, but that I think reveal that COVID-19 is not actually so different. So one is a study of a high-rise apartment building in Korea where the transmission seems to have been along a plumbing stack into apartments that had dried traps, just like Amoy Gardens in Hong Kong. And another study also in a Korean apartment found a number of vertically distributed infections in apartments that shared two common ventilation shafts. So these were connected to the bathrooms, and they were natural ventilation pathways. So air under the influence of stack effect could actually go in and out of any given apartment depending on what the temperature was outdoors. And this seems to have been the common element there. So all of this suggests that we need to be even more concerned about airborne transmission, especially with more infective strains coming that may require lower exposure to cause an infection. So that's our background, and now what I'm going to do is review the current status of ASHRAE guidance, and I certainly can't go through 300 or 400 pages of detailed guidance documents for you. So I'm going to focus on what I think is one of our most important products in recent times, which is our core recommendations. These were developed as a concise statement of the framework of ASHRAE guidance for two purposes. One was inward facing. We have 15 teams that are working on different aspects of guidance, and over time they can become a little bit siloed and drift apart in terms of what they're saying. So this was partly to help keep us on track internally, and we're in the process of updating all of those longer guidance documents to conform with these core recommendations. And the other was the outward-facing purpose. Many have found the lengthy guidance and the resources website hard to negotiate. So this is a way of communicating some of the basics of airborne risk reduction in a very concise and simple way. And also, because guidance has been changing over time, to document what the current status is of guidance, which is another important thing. As I mentioned, some are still referencing the infectious aerosols position document as ASHRAE guidance, and some are referencing articles that aren't even products of the task force as ASHRAE guidance. So we're trying to stop that from happening. So the first area that the core recommendations address is public health guidance, and the basic message here is that we should be following public health guidance, specifically with respect to distancing and wearing of masks indoors and other measures that are recommended. Just because you've improved your HVAC system doesn't mean that you've now relieved yourself of the need to follow other guidance. Why is this important? COVID-19 is transmitted by multiple different modes, and HVAC only affects one of them, airborne. So we still need to be doing things that will help control close contact and, in case it exists, fomite transmission. And the other reason is that mask use is very significant in terms of its ability to reduce the risk of airborne transmission, because it blocks jets that might be produced by coughs and sneezes. You can see the well-known by now image of the sneeze traveling 8 meters away from the source in the upper figure. And in the lower one, you can see that wearing even a cloth mask stops that from happening, and also will substantially reduce the amount of infectious material that's put into the air, and will provide some protection to uninfected wearers. So this is really, really important even for airborne transmission. The second group of recommendations relate to ventilation, filtration, and air cleaning, with outdoor air being the first issue addressed. And of course, for we engineers, this is probably the most important section. So the first is to maintain at least the required minimum outdoor airflow as specified by codes and standards. Why is this important? Our early guidance suggested that you should try to maximize outdoor airflow, but that's energy intensive and expensive and may affect comfort. And over time, and looking at different approaches to risk management, we've concluded that other controls may be as effective and more acceptable in terms of energy use and cost. But code minimum ventilation should be mandatory because it's required for general air quality. What we're saying, however, is not that it's sufficient. What we have to do is look at the totality of all of the controls that are in place and assess their combined effect, which is another important update to guidance. And moving on to filtration, we've now come out with the statement that we should use combinations of filters and air cleaners to achieve MERV 13 or better levels of performance for treating recirculated air. We still believe MERV 13 is the right efficiency level to target for filters, or EPM 150 if you're in Europe. But clearly there's problem for some that they can't get to MERV 13. What else can you do? And what we're suggesting here is you do the best you can and supplement it with filters and air cleaners to reach that level. Important because standard filters aren't effective for infectious aerosols, so we need to upgrade. It's also important to make a statement that would rule out the need to put HEPA filters in central systems. We believe MERV 13 is a good compromise, and this allows trade-offs when we can't do MERV 13. And just to reiterate why we do that, here is an image of the spectrum of respiratory aerosol droplet sizes, and overlaid on it are the 3 size ranges in which ASHRAE standard 52.2 rates a filter. And you can see that for MERV 8, which is the filter efficiency that is specified in ASHRAE standard 62.1, we only have a minimum efficiency requirement of 20%, and that's in this region where most of the respiratory droplets are. So by going to MERV 13, we moved from 20 to 70%, or 20 to 85% in that range, and from 70 to 90 in the largest size range, and from no requirement to 35% for the smallest size range. So this is a big upgrade that has a very significant effect. We also have a statement about air cleaners, which is a little bit cautionary, and that is use only air cleaners for which there's evidence of effectiveness and safety that is clear. I think we all know that there are many air cleaners, air purifiers that are in the market that, if you probe deeply, don't have a good evidence basis behind them. At present, the only one that ASHRAE feels has a truly strong evidence basis is germicidal ultraviolet-based systems. ASHRAE does not say that other technologies don't work, but we do say that we haven't been convinced by the evidence we've seen that the due diligence to demonstrate effectiveness in application and safety has been met by all of them. So users are really on their own until we get methods of test and certification programs to evaluate the evidence that's available. ASHRAE is trying to assist, but there are limits to what can be done in the current environment. All right, so we've talked about the three different controls. This is very important, the issue of combining controls. So select options that provide desired exposure reduction while minimizing associated penalties. It's important because it defines an approach for selecting controls to meet some overall risk target. What is that target, of course, is a question that is important, and we're still working on it. It's consistent with what we call an equivalent clean air or equivalent outdoor air delivery rate approach, and we hope to publish something on that soon. The big benefit is it's a way for each owner or their engineers to come up with strategies that work best for them in terms of cost and energy efficiency. So how do we determine what these targets should be? The Wells-Riley equation, the Wells-Riley model, has been used extensively as a basis for analyzing infection risk during the pandemic, and it still remains probably our best tool. It has its limitations, but with the Wells-Riley model, we can set a target for infection risk, and by defining a scenario where we have a assumed number of infectors and their output of infectious quanta and how long they're in an environment with susceptibles and what the pulmonary respiration rate is of the susceptibles determines the size of their dose, we can determine the clean air flow rate that's required to achieve that target. So this is the basic approach. There are lots of details to be negotiated, but we can do that using data like the Buonanno et al. Infectious quanta estimates for SARS-2 for different types of activities, but recognizing that they're pretty uncertain. We have two orders of magnitude range for any given activity between the 5th percentile and 95th percentile. So it makes sense to choose a conservative value, but these are not highly accurately known. But it is important because we see when we look at Wells-Riley model solutions that what you pick as an infectious quanta number has as much to say about what the predicted risk is as how many air changes you're selecting. This is an example for an office environment where there's 8-hour occupancy and speaking is the activity going on. So with the Wells-Riley model, we can interpret that clean air quantity as the sum of actual outdoor air and air cleaned by different methodologies, by passing indoor air through a filter or by using an air cleaner. So, for example, for a portable air cleaner that's rated by the Association of Household Appliance Manufacturers, we may have a clean air delivery rate, cubic feet per minute or liters per second, and we can turn that into an air change rate if we want to, and we can add together air changes for outdoor air and that air cleaner and other things. So with our design clean air delivery rate or clean air change requirement, we can add up controls to meet that total. So that's the approach that we're moving towards, and that's what others have already used in some of the published literature. A third area where we've provided some guidance is on air distribution. This is a developing area that we're still working on as a research topic, but we do have some recommendations, and we address mixing and drafts. So where directional airflow isn't specifically required or not recommended due to risk assessment promote mixing of space air without causing strong air currents that can increase droplet transmission from person to person. This is important because there's some evidence in the literature that stratified ventilation, which we think of as being good for air quality, can trap infectious aerosols. There's good research on this from several well-known ASHRAE members and European air quality researchers that supports that point. And we certainly have seen that strong drafts can transport large droplets that we would not have thought of as aerosols over long distances. So why are we saying this? We had this recent case study from a Korean restaurant. A lot of the good forensic work's been coming from Korea lately. So we have one infected person sitting here along the wall, and there were 3 infections, the person dining with them and 2 others who were 5 to 7 meters away. Very interesting things about this case. This person was only in the restaurant with the infector for 5 minutes, and this one was only there for 20 minutes, and no one else in the restaurant was infected. The analysis of what was going on revealed that there was a 1.2 meter per second horizontal velocity that was the result of these VRF cassettes in the ceiling creating a strong air current. So that's pretty clear evidence of this potential for drafts to contribute to infection. And this image on the right comes from an article in the ASHRAE Journal by Hugo Lee and Peter Nielsen and Matt Sandberg, all of whom are very well-known engineering researchers and scientists, that shows how exhalation, if it's the source of contamination, can escape the plume that normally would contribute to removal of contaminants in stratified ventilation. And this can hang in the air for a long time and contribute to infection. So this group recommended for a lot of healthcare environments mixing ventilation, and we're adopting that provisionally until we have more information on whether stratification can work effectively. With respect to HVAC system operation, we have a number of recommendations as sort of a catch-all category, but it covers many things. One is to maintain temperature and humidity design set points. If you think back to the position document, there was a recommendation there to consider changing humidity set points in particular to limit risk of infection. And we've stuck to the position that whatever your set points are, you should keep them. If you have humidity, that's great, and that may help. But humidifying buildings that aren't humidified already can be a problem. Why this is important and why this is the recommendation, we feel that the impact of humidification is not the same as other controls. It's lower in effectiveness than, for example, more ventilation, better filters, some types of air cleaners. Maybe worth an air change per hour in a good situation. We can put in UV and that system will do 10, 20, 50 air changes per hour equivalent. Another is that many buildings are poorly suited to add humidification, particularly if they're in cold climates. There was a lot of pushback on the original recommendation. The systems are expensive, and there's limited ability to adjust occupied zone temperature set points because of comfort. And we do have research that shows that even though there actually is significant variation in viral lifetime as humidity is varied, when we consider the overall impact on removal, it doesn't have much impact. This is some work on influenza by Lindsay Marr at Virginia Tech in the US. Here, this is the case with only 1 air change per hour of ventilation, and we still have a pretty flat total removal curve. At 10 air changes per hour, which we could get to with combining all of our controls, it's nearly a flat total removal curve. Another thing that's been covered in the recommendations is flushing of or is maintaining ventilation during occupancy. We don't need to maintain ventilation 24/7, but we should have the designed ventilation whenever there are people in a space, including janitorial personnel and maintenance staff after normal business hours. This recommendation discourages the use of demand-controlled ventilation to reduce ventilation below that design occupancy amount, because that will save some energy, but will also significantly increase risk. And again, it underscores the need to ventilate whenever there are people present. We've also addressed the issue of flushing between occupancies. And again, this ties back to the 24/7 recommendation that was made initially. We found, after reflecting on it more, that it really didn't make sense to operate systems 24/7 when perhaps a third of the time there was no one there. Given the removal rate by ventilation and filtration of contaminants in the air and the natural decay of active virus, that doesn't seem necessary. So our recommendation now is that when there's a need to flush a space between occupied periods, say between class periods when we're having a changeover of classes at a university, operate the system long enough to provide 3 air changes of equivalent clean air supply. Emphasis here on equivalent clean air supply. So it doesn't need to be 3 air changes of outdoor air. If we can take credit for what filters and air cleaners are doing, we might have, instead of an hour of flushing with our outdoor air supply, 3 air changes per hour, this might take 20, 30 minutes. So it's important because in some cases we really do want to clear residual contamination. It's important because we need to be clear that our original 24/7 recommendation isn't supported anymore. And considering just a perfectly mixed space, 3 air changes will result in 95% removal. This can be adjusted for other targets. 99% takes 5 air changes, and you can adjust this for ventilation effectiveness as well. And you may have seen that there's now a tool available in the building readiness guidance from ASHRAE that allows you to take all of those things into account. We've also addressed the issue of reentry, and what we were thinking about here initially was our conservative recommendation with respect to energy recovery wheels. Now the recommendation is to evaluate the risk of reentry and make sure that's limited to acceptable levels, given that we can't completely eliminate it. This is important because we did have that initial advice to just turn off energy recovery devices. We've learned that it's possible to operate many of them if they're configured properly, and provided guidance on how to assess that. And this also addresses other sources of reentry. So think back to the examples we looked at before, the ventilation shaft transmission or plumbing. So those also fit under this recommendation. And given those 2 case studies I showed, we may actually update this to say something specific about those sorts of risk factors. And then the last recommendation has to do with system commissioning, to verify that our systems are going to function as designed. Why is this important? This is someone everybody knows and we sometimes don't talk about, which is that there are an awful lot of systems that are poorly maintained, and we have really no clear idea of how they're performing from an air quality point of view or from an energy point of view. So we don't want to have systems that are unpredictable in terms of their ability to protect occupants during the pandemic. We can see in the graphic over here on the right the state of schools in the US. The government agency, the GAO, evaluated the state of infrastructure in schools, and the top problem they found was HVAC systems. 41% of school districts with 50% or more of their HVAC systems in need of upgrades or replacement. And if we go down the list a little bit, we find more than 20% that had issues with windows being operable. So this is a big problem, and we feel that not only will this make buildings safer, but retro-commissioning also is generally understood to save a significant amount of energy. So this will help to pay back the energy cost of controls that may require some additional energy expenditure. So those are the core recommendations. And now just a few brief thoughts about the future before concluding. I think that certainly something that is coming after the pandemic is a higher profile for indoor air quality generally, and more desire to do something about it as our pandemic experience merges with the experience that we're having with wellness in buildings and that emerging movement. I think we'll see indoor air quality standards that incorporate in some sense resilience, and that will change system design. And this is not simply measures to make buildings able to respond to infectious disease epidemics when they occur, but also dealing with events like wildfires, which are a big problem in the Western US and have been in Australia and other places in the world. So having standards that go beyond just dealing with business as usual. We do this for seismic design in buildings. We do it for hurricane and flood design. Why shouldn't we be viewing protecting the occupants of buildings during extreme events as an aspect of resilience? I think we'll also see a lot of investment. I certainly hope we'll see a lot of investment in research on how air cleaners actually work and the development of standards by which they can be rated, because personally, I believe air cleaners are a big key to a sustainable future with high levels of IAQ, but we're not going to get there if we don't have air cleaners that are well characterized and that we can rely on. I think we might see changes to filter rating standards. The attempt to use MERV ratings, for example, to specify filters has been problematic because we don't actually know how a specific filter performs. We only know what the minimum criteria are for it, and I think that that's experience that may feed back into the development of those standards. We're going to see and need better coordination between energy and IAQ objectives and standards, perhaps energy standards that recognize what it takes to do better air quality design instead of simply trying to squeeze energy use down as far as possible. And finally, I think that education is important. Webinars like this and all the others that many others have provided, I think, are educating the whole industry about some important fundamentals related to air quality and infection control. I think that needs to make its way into our standard curricula so that we start producing a new generation of designers and facility operators who are aware of these important issues. So with that, I can summarize that ASHRAE's initial guidance, like that of others, was conservative, not prioritized, and in some sense semi-quantitative. We took a lot of feedback on board about economics and energy and used that to change what we were recommending. We're also referring now to quantitative risk models to help inform our efforts. So that has resulted in current guidance. It's more flexible, less conservative, but still capable of achieving an appropriate level of risk reduction. I want to put in one more plug for masks use. I think that we've only seen evidence over time that it's more important than we might have thought initially, and that's especially true with more infective strains emerging. Our highest priority in ASHRAE is to come up with these recommendations for clean air supply rates. There are some available in the literature, but ASHRAE really needs to produce its own recommendations in that area. And finally, I think we'll see multiple changes to standards and then possibly new standards as a result of what's been happening. And with that, I will conclude, and I'll show you that nice new updated infographic again. The core recommendations are right here. And if you're familiar with the old one, you'll see that we've added some new guidance here since the first one. We've got laboratories and we've got communities of faith, and there are more coming. So I'd be happy to take questions and comments at this point.
Thanks very much, Bill. And just right on time. So clearly you've done a lot of these, and it's thank you very much. It's been a really interesting presentation. There's lots of questions coming in. We probably won't get around to all of them, but we'll do our best to try and capture the most of them if we can. One of the first ones that popped up was regarding why it took so long for the CDC and the WHO to acknowledge the airborne infection route for COVID.
Well, one could speculate a lot about why that was. I think one reason is that epidemiologists are not aerosol scientists, and I think there is an understanding of the difference between aerosols and droplets embedded in their thinking that goes back decades, that only 5 micron and smaller particles can travel a long distance, and that if you're close to someone, it's the droplets that are doing the damage and not the aerosol you're emitting that's being inhaled. So yeah, that was part of it. And there was also, I think, there's a different kind of proof that medical professionals expect. They're a little bit less likely to view case studies like the ones that we relied on as being conclusive. And there was also, at least initially, a legitimate issue about supply chain for the masks that healthcare workers needed, the N95s. And I think they were afraid that the conclusion would be that everyone needed to be wearing an N95 mask. So those are some of the factors, but the important thing is that they've come around and they're really engaged in a very healthy dialogue with other expertise now that I think is moving us in the right direction, maybe still slower than we'd like.
Thanks very much. There's a lot of questions coming in on specific technologies and types of air cleaners. I know you mentioned this during the presentation as well. A couple of the technologies mentioned were bipolar ionization, plasma-based ozone systems, dry hydrogen peroxide. Is there any recommendations that ASHRAE has produced on specific technologies, or is it just in relation to UVGI?
Well, again, the UVGI recommendation comes from, I think, the original Airborne Infectious Diseases position document. That committee looked at all of the available evidence and felt that there was enough for UV to say that it's effective and safe, and that's something that's I say reinforced by the fact that the CDC in the U.S. approves it for tuberculosis control. So, that's a much different situation than these other reactive species air cleaners, for which there isn't much archival literature, peer-reviewed literature, a lot of commissioned research studies that in many cases are not very accurate in terms of reproducing application conditions. And so what ASHRAE is doing is continuing to encourage those who are manufacturing those products and interested in them to support research and to work to develop standards by which they can be rated. Unfortunately, it takes years to develop a good method of test standard. And we really fall back on CDC statements that agree with what ASHRAE is saying, that some technologies just don't have the strength of evidence base behind them to be able to endorse them at this point, but we don't rule out their use.
Thanks very much. There was an interesting question about regarding the new variants that we're seeing of the virus, and for example in Ireland the British and South African variants of COVID, and I think you showed on slide 24 the quanta rate that's used with regard to infectivity. Do you have any comment about the I suppose the impact of new variants in how we model and mitigate COVID?
Well, the comment is at this point I'm still a little bit unclear myself about what it means to say that something is 30% or whatever more infective than the current strains. Does that mean you should multiply your quanta by 30%? I'm still thinking through that, and I think others are as well. The the implication is that whatever we're using as quanta estimates need to be increased somehow, but I don't know whether that's a simple multiplier, because you're putting it into an equation that's exponential. So maybe the thing is that you put in the quanta that you've got and multiply the risk by 1.3 or something like that. I'd say this is really there's not enough science yet behind it to know what the right approach is, but it just suggests that whatever we're doing, a little more conservatism is a good idea, and especially mask use.
Thank you. There was a couple of questions about monitoring systems as well. One in relation to, I suppose, the amount of time required to commission systems manually, and any ASHRAE recommendations about alternatives, database, monitoring-based commissioning, and also in regards to indoor air quality monitoring solutions, so monitoring PM 2.5, TVOCs, CO2, and your thoughts on that.
Yeah, well, as far as commissioning goes, there's a lot of guidance on what sort of checks ought to be performed in building readiness that kind of describes the full boat approach. But if you have many buildings and then it costs thousands of dollars per building to recommission them, that may not be feasible. I start with the most important thing is look at your design documents and figure out what they should be doing. And if you've got data that you're acquiring continuously with a EMS or something like that, then that can be a source of data. To do whatever you have the ability to do within your time and budget. Ventilation and filtration are obviously the most important things to check. What was the other part of that? I had something I wanted to say about the second part as well.
The second part was in relation to indoor air quality monitoring systems. So monitoring like DM and TV.
Right. Obviously, since a particle sensor doesn't know the difference between a particle with virus in it and one that doesn't, I don't think that measuring PM actually tells us a whole lot about infection risk, although it's something that I think should be measured just as an indoor air quality control. We don't have affordable, accurate sensing for specific microorganisms yet, so that's kind of ruled out. And ASHRAE and REHVA have taken somewhat different paths with respect to CO2. And others as well. There are many who think that CO2 concentrations are a good indicator of whether a space is safe or not. And I keep coming back to my analogy that if you have 10 people in a space and one of them's infected, you have a certain CO2 concentration. And if 8 of those uninfected people go away and there's one infector and one uninfected person, the risk for that person individually is exactly the same as it was before, but the CO2 concentration is a lot lower. So I still remain a little bit skeptical that measurement tells us anything about good ventilation, although a really high value would be suggestive that we had bad ventilation. So I think it has less value than some are ascribing to it.
Thank you. Might just get one more question in. There was a comment regarding displacement ventilation. So displacement ventilation has a ventilation effectiveness greater than 1.2 to 1.4, which in theory makes it more effective, so better for COVID, but this may lead to stratification. So is the ASHRAE recommendation that we don't use this, or should we apply a reduction to the ventilation effectiveness?
Well, if you have stratified, one of the reasons that we haven't gone much farther with air distribution than we have is that how feasible is it to change the air distribution in most buildings during the pandemic? I think we're going to be looking at recommendations for what we do with new buildings, but I wouldn't try to necessarily change a stratified ventilation system if I had one, although putting some fans in to mix could help. The reason is that close contact is one of the major transmission modes. And if people are going to be in a space a long time, mixing may result in the lowest average exposure. And that's in opinion of Nielsen and Lee and others. They're also in this Morawska group that I hang out with, and we've had a lot of discussions about that. So it's just not very clear yet. I encourage everyone to read that really good IEQ column from the ASHRAE Journal, which will point you to some more references about how this stratification of exhaled contaminants can happen. It was really an eye-opener for me, because we tend to think that stratification is beneficial all the time, but we forget that we're mostly talking about generally produced contaminants like VOCs or contaminants that are produced by a person that go directly into their thermal plume.
Thank you very much, Phil. I think we'll wrap up the questions here. Apologies to any questions we didn't get to. We'll do our best to follow up afterwards by email for those that we didn't get round to. So I'm just going to move over to some brief closing announcements. Okay, hopefully you can see my screen. So just to mention just a couple of brief closing announcements. Firstly, the ASHRAE Winter Conference will be held virtually from next week, Tuesday to Thursday, with 8 conference tracks and over 120 live and on-demand sessions. So you can view the full program on the ASHRAE website. Just to highlight here, there's an offer as well for non-members. If you register for the conference, you'll also receive a full year of ASHRAE membership as part of that registration, which also includes the ASHRAE handbook, subscription to the ASHRAE Journal, and more. We'd also encourage any attendees to have a look at ASHRAE's technical committees and get involved if you can. These cover a lot of different aspects of ASHRAE's content, from fundamentals through to building applications, indoor environmental quality and controls. It's free to sign up as a corresponding member, or just have a look at the technical committee web pages to see the latest activities. At a more local level, you're also welcome to contact us at the ASHRAE Ireland Chapter Board. There's a number of vacancies at the moment, and we're always interested in hearing from anyone that's interested in volunteering. So feel free to get in touch with us if you want to learn more about ASHRAE in Ireland. If you want to stay up to date, just make sure that you're registered on our mailing list on the website, and follow us on the social media links that we've provided. So lastly, just thanks again to Professor Bahnfleth for your time this morning, and to all our sponsors and supporters for your ongoing support for ASHRAE activities in Ireland, who make our work possible. So thanks everyone again for joining, and for a really great engagement from everyone in the audience and the questions that you've asked. And we look forward to hosting another webinar very shortly. So thanks again, everyone. Goodbye for now.